Hey everyone, welcome to another Common Lisp study group. I'm your host, Ram Bedam with Atlanta Functional Programming. Today we're going to be discussing the Parenscript library. The Parenscript library is a library which I hope many of you know about, but if not, welcome to our episode because this is a good introduction for you. Parenscript has been around for a very long time. It's a library that cross compiles common Lisp code and gives a Lispy interface to JavaScript. It originally started out, at least the first time I've heard of it was at least in 2000, I think 6 or 7, when I was very early on when I was starting out on Common Lisp, particularly because I vaguely recall it was either slightly mentioned in or briefly talked about inside Practical Common Lisp, along with CL Who, which is a wrapper library that one of many one of many Lisp libraries that was created by the author of Practical Common Lisp, Peter Seibel, or it was taken out of his design and created into its own library. Parenscript originally was focused on a complete cross compilation, a transpiler, so you could write code in Common Lisp and then set it up so that it just generates the JavaScript. And in particular, it was designed in such a way that you could write your stuff on the fly. As many of you probably know, reading some older blog posts on Lisp on the web and so forth, originally Lisp code and folks who were writing web applications in Lisp, and this goes as far back as even the days when via web was being created, they would write their Lisp code that would auto generate the site plus whatever JavaScript interaction once JavaScript became standard in the late 90s. And then they would deploy that on a server that is a Lisp endpoint that using whatever proxy server that they were using would redirect the HTTP request to the Lisp web server. At the time in the late 90s, it was probably running something on either LispWorks or what's it, Allegro. But in the early 2000s, Edie White's Hunchin' kind of became kind of the serva franca, right? Kind of lingua franca, the server franca when it comes to deploying a Lisp web app um, that auto generates the HTML and JavaScript when a request comes in. Today, we're going to be just briefly covering the language because it is my hopes that over the coming weeks that this will turn out to be a good detour into actually doing web programming in Common Lisp, and in particular, hopefully, creating static websites in Common Lisp. My intent is not just to show that you could write basic websites in Common Lisp using CL Who as well as Parenscript. But also, if you want to follow modern web standards or modern web architectures, you could certainly do so through Common Lisp has a middle language that can transpile down to vanilla JS, much like using, say, TypeScript or even Dart or any of these other languages to generate your code. One of the reasons one might use Common Lisp just mainly is, and I know it's like beating a dead horse or even like repeating the obvious, macros. Macros gives you the ability to actually go and generate custom mini languages if you need to extract common patterns inside your business domain in such a way that when you are actually generating your site, those are actually declared inside your file, which obviously improves maintainability because it is your company's or your personal coding standards that kind of influence design, and it's not something that uh, fits any particular narrative based on a framework that you're leveraging. Of course, you could use any other languages in much of the same way. But remember, a lot of times these languages end up coming up with their own idioms and standards that, uh, although they say that they're not creating a domain specific language for a framework, they're using the general purpose constructs to create an API. I am of the opinion, and this is just my opinion, for folks who want to have a much larger discussion, feel free to ping me on my various accounts, including Twitter as Unix Nerd or Bugram on both the functional programming Slack as well as the Lisp Discord server. But it is my opinion that API design is language design. You are dealing with a language, you are communicating specific operations and returning data types. And if you're not thinking correctly about the logic on how those gets constructed and how they should be invoked and how they should be generated, then your API is going to be very restrictive. In many cases, might be buggy based on the use case that you're developing. Um, Today, we're going to be starting with some very basics. I'm just going to give you a quick overview of the language, and what I mean by language, the API, and how to leverage Parenscript. Parenscript, as I mentioned, is available in uh, Quick Lisp, and for folks using QLOT, you can certainly add it to your QLOT file. For today's purposes, I'm not going to use a QLOT project. I will show you this at a later point when we start actually building up a proper web application in CL. But Parenscript, as far as Quick Lisp is concerned, comes in two flavors. There is the original Parenscript or Parenscript Classic that was released way back in 2011. That is when Quick Lisp kind of came out. This is one of the libraries that was posted up there at that time. Um, Parenscript is actually older than Quick Lisp is in terms of the lineage. And then someone I think took it up or moved it off of Darks over to GitLab. If I'm not mistaken, it's either GitLab or GitHub, and they started maintaining it again. And the latest version, as of October 2021, as you see, one is Parenscript 2.71. Now, most of the stuff that we're going to be covering today should work in both of those versions. It is my hope when we start dealing with, say, using a library that uses more ES 2016 features, whether it be objects.arrays or objects.clone or even uh, what's it the class syntax, that we can actually go and leverage that in much of the same way, so that way folks reading the generated code, they could see it's a one-to-one thing. But we'll see as we go along. I haven't actually touched, for full disclosure, the newer version of Parenscript, so I'm going to be learning along with you to see what limitations are around with this library. So let's go ahead and load this into our um, image here. As usual, for folks watching, I don't think I need to mention this, but if you have any questions, feel free to post them in the chat for our members, and I will answer them as quickly as possible. If you're watching this at a later time, by all means, go ahead, put your comments in the YouTube comment section, and we will address them as we see them. So with Parenscript loaded, as you can see, Parenscript didn't really need that many dependencies. We can get started. Most of the stuff that you could see with Parenscript is actually an exported symbol. We're going to start with a couple of examples first, and then we'll start create a basic project, because a couple things related to files will become clear, but I will point them out as we go along. So Parenscript actually comes up with a lot of stuff that maps directly from Common Lisp. Okay, so your def bars all actually are properly created has uh, um, are actually your def bars are actually going to be properly compiled to when you compile them to JavaScript to use the appropriate JavaScript syntax. When you have this basic def bar here, all right, to generate the uh, actual Parenscript stuff, you need to actually do the following. Um, you need to call the, if I remember correctly, just PS colon compile expression. Um, compile script. Yeah, compile script, and it will actually end up generating the file, right? Yes, it will generate the standard out. Okay. So if we take this and then simply call PS compile script and takes the form, this will return file script is definite use PS star. Okay. This will generate a, and this is a style warning, but right, I'm gonna have to probably print this guy out like this. You'll see it will generate a my global here. All right. Um, let's create something a little bit different here. And let's actually use, it looks like compile script is the old way of doing this, which means that I may be using older notes here. So let's go ahead and see if we could use PS star. Okay, and let's do that now. Okay, so it's nothing major here. This is just changing slightly different. What is the slight difference between now PS star and PS compile script? Compiles in JavaScript stream if parent script is bound output. Otherwise, otherwise it returns a string. Okay, interesting. Okay. So, as you can see here, what we have is we defined a program, a script, but it didn't actually go in and give us an assignment. So this is kind of weird. Let's look at something a little bit more. Uh, that's kind of odd. Um, the bar creates. Um, this is still generating that. Okay, so let's do this. Um, let's create a different bar. 1, 2, 3, 4. I bar. Kind of show you guys different ways of doing this. If you see here, Parenscript just takes the list forms that you have as is, and it will actually just go, and in some cases, in this case, on our let form, it'll actually go in and you know, do constant folding and actually dump the actual value. It won't actually create the let block and then generate these stuff. So this allows you to actually end up creating, lexically scoped Lisp code that will actually generate the, depending upon certain flags and things that you're passing in, different types of code for in your compiled JavaScript. Um, Now you also have in Parenscript the ability to take, say, a function, say like hello world, and let's go ahead and do the proper hello world. I don't believe you can actually just simply say print hello world. It will actually generate, I think, the print function call. What you want to use is ps slash alert. Actually, not even ps slash alert. You could just simply use alert because alert is actually generated into our standard JavaScript syntax. Uh, and it will go ahead and compile a function in the standard JavaScript syntax. I'm going to show you the generated JavaScript in a minute, but one thing to note about Parenscript allows you to take any already known JavaScript functions and use them directly as if they are Lisp functions. All right. Since at the end of the day, your JavaScript is not executed inside of the Lisp image, it is actually compiled into JavaScript. You will almost are guaranteed that the code has, as long as you don't have any typos or anything like this, it will work. Now this allows you to say mix JavaScript with with common Lisp. So for example, let's say for hello world we wanted to go in and create a string, okay, but instead of using just hello world, which will work, and you'll get hello and world. um Second, what is this? Hello world. Hold on. I think this is actually evaluating. This might be the wrong one that I'm looking for. Um, PS PS to stream. Oh shoot. Or stream. Okay. And output. Oh, to generate. There we go. So, I was using the wrong function. Um, Let me do one thing here. Do this up. So we're going to use PS to stream just to generate the code as we are expecting it to. So let me return to what I was going to show you here and say alert hello world. You can see here what this does is it will generate an actual alert, and ignore this underscore register stuff because that's, I think, used by Parenscripts to do some optimizations later on. I haven't actually figured out in the documentation what exactly this specific piece of things has been around, but obviously that is something that might be newer to the Parenscript world. Um, this not only allows you to do this, obviously this is pretty simple. You're actually calling a function. The fun will actually go compile to function. You have alert hello world. We're okay with this, but you can also mix, as I was saying earlier, PS to stream standard output on another hello, and we can actually say, and let's say that in this case, um, we're going to grab a name here and we wanted to connect to it, right? Now, I'm sure uh, you might be thinking that, oh, this might be a time for us to use like format nil and then use a format string to actually go and generate this. But actually, you'd want to use concatenate because concatenate allows you to um, specify the output that you're trying to jump into and one or more things that you want to have concatenated, and we'll go ahead and concatenate them. The one thing about format is with respect to Parenscript, if memory serves me correctly, is it, and I'll show you an example of this just so to illustrate this point. Is format doesn't actually translate into Parenscript as one might think. So if we go ahead and do this here, you can see now we have our function hello name, and it'll go ahead and do a proper concatenation pass to alert. Now, couple notes here. You might be noticing that we're seeing it generated twice every time. This is not actually generated twice. This is the precompiled return string, and then it actually returns it. There's two values that are being actually returned. But the actual string representation, and it's dumping it to the console. So if you go and look at ps2 stream, what it's doing is it's actually taking the Parenscript forms, compile them at macro expansion time, and then it writes the resulting code into the appropriate string, the stream object that we passed into. All right, this allows you to, in some cases, say generate code directly into a file. All right, and set that all up upon in real time. So there's a lot of ways of using this. This is one of the reasons why I wasn't I was trying to avoid using PS to stream, just because PS to stream um, converts it this way, and it doesn't. I thought it was used at a higher level when we call out to it, but it looks like if we go and use PS star, as you saw before. Hold on one second. Uh, there we go. You see here that we get uh, not only an incorrect output, we're seeing actually that it's attempting to evaluate it. Um, we'll see more of this when we go into compiling files later on. But for now, I'm just going to keep this thing right here as it stands. Right, right. Clear. Um, Most of the standard common Lisp library notes that you might be familiar with actually map directly. And this includes if you use, say, for now, I'm just going to go ahead and make this into a simple function because we don't want to really constantly hit a print JavaScript form. Um, Actually, let's make that into a macro and at body forms. Okay, actually, we may want all of these in the same set of forms, but that's okay. That should be fine. So I won't need to splice it, and we could then just do this, print stream, and for the time being, I'm just going to go ahead and just you don't need to even do that. Let's go ahead and do this. Yeah, no, this standard output, and we'll go ahead and say forms. Because that will be the list of forms that will be passed in as a list. Okay, so we have this. Let's go ahead and generate this guy. Um, Print JavaScript. Let's do a little test to make sure this is all good. Um, Test 2, and there is a form. Defining it, and not a macro form. Of course, it's a macro form. It's one, two. test nil2 cannot be compiled into an expression. Oh, let's see. Um, that is wrong. I thought it was, need to use this. Fine, my macro is incorrect for some reason. Uh, you know what? I make it a macro when when you can make it into a function. Sometimes I'm picking the wrong stuff that should be part into it. See here. Uh, um, oh, right. We need to restart my list because for when you're redefining a macro, it's going to end up causing some issues. Um, no, no, no. This has to be a macro because this is a. I want my Lisp forms to be passed in. Um, Foul warning, compilation using undefined function. Oh, right. I forgot to compile this again, didn't I? There we go. Defund test. Oh, I made this into a list. 1 second. There we go. Now everything is working as I expected to. So, um, that was really weird. I don't know why it threw that up because that's what I had before, but it looks like body forms kind of made a list of lists and it just didn't recognize that. Okay. Um, so uh this will actually go ahead and generate a just a this is just a simple macro that's going to actually generate forms. This is a convenient function for us to actually leverage what we're going to be talking about. Uh oh, as you saw earlier, it actually takes in a list. So we don't need to worry about this. We can actually do 1, 2, 3, 4, and it'll go ahead and generate the appropriate list. What's funny about this one is you can actually go ahead and do this, say, and call list functions, and it will actually go and appropriately map it out to the appropriate JavaScript call, which is pretty cool. Um, Obviously, once you've defined a function, you may want to call it. So, say that we have this function here, we have our test function, and we want to call it. Calling this, you'll see that we'll actually convert it into an appropriate test. And this is for both um, uh, calling functions with parameters or functions without parameters. Notice another thing for folks who are paying very close attention to the generated code. The generated JavaScript code is using single quoted strings, not double quoted strings. Okay. One thing I've noticed is a lot of the generated code is going to be single quoted strings. I don't know in what case you can get a double quoted string and how you can get it. This might be useful in some cases. I don't think it does because in JavaScript, if I remember correctly, single quoted or double quoted will still get do the appropriate comparison as I'm expecting it to. But obviously, I don't quote me on that. Defining JavaScript functions, sorry, not functions, sorry, arrays, like dynamic arrays is something pretty useful to note. Okay, so if you ever you may have seen some of these basic data structures that are available in JavaScript. This is stuff that I'm just shooting off the top of my head because it's been a while since I've actually written any serious JavaScript. But in immediate comes to mind is if you have let's do the actual Lisp calls. You have list, which will generate sorry. Um, and standard list there. This is a heterogeneous list. You can actually generate this in JavaScript. You could also do, okay, and I'm gonna just gonna print out all these different ways of calling this. So you have list, you have array, you have make array, right? And then in JavaScript you also have you that's the Lisp call, but you can also call new and then call array um, by saying dash array, and this here will generate the same code. Okay, I'm going to illustrate this to you in a minute. Um, uh, and um, so let's look at this. So let me go ahead and clear this so we can compare all of these. So in the first example, we see 1, 2, 3, right? Um, but in the second one, we also see 1, 2, 3. Right now, both are valid approaches because remember in JavaScript there's no notion of a there's a notion of an array, but there isn't a linked list kind of like structure as far as I know. I don't believe there's any way of actually um, generating that. That there's only the list, the array structure. You could probably mimic it by doing some including object stuff, but by default in the standard there isn't, and we're only talking about converting standard JavaScript over to using Parenscript. All right. Um, Now let's show these two different ones. This is particularly interesting. Make array for folks who are watching along. This is actually straight up from Lisp. So Lisp, remember, has a make array where you can specify the dimensions and all this stuff. But in our JavaScript transpiler, the make array is just nothing more than an alias to calling new array. All right. So if you go and call this and compare this to this, you'll see the same kind of approach to generating um, new. In one case, you see uh, new being called like a function, and in the other one, um, you're using new as a keyword. Um, I don't know in what cases this specific example, the new tiller array is useful, but keep that in mind. It is at one point they used to be the same, but it doesn't look like they're dealing with that in the same way. All right, let's talk about objects. Everyone knows about JavaScript objects, so I really need to go into too much detail. In JavaScript, you can actually go ahead and generate a basic JavaScript object by just simply doing a def my object and use the in Parenscript you can create a new object, JavaScript object, by just creating the curly braces. This is actually treated as an object with no properties in JavaScript. If we go ahead and compile this, we'll see that we'll say if undefined type object, you'll get my object. Now, please note that Parenscript automatically generates the appropriate strict guards for us to check to see that my object, since it is written in the global scope, okay, pay attention to the capital letters being generated here. That's actually a common notation for a lot of stuff that's generated by Parenscript. Um, the object is guarded to make sure that it is undefined, not null, undefined, okay? Remember, null and undefined are two very different things inside JavaScript. Okay, um, For folks who need some more advanced tutorial for JavaScript, I encourage you. There are plenty of great books on JavaScript. I'm only going to be paying attention to kind of the translation between Parenscript and JavaScript for the time being. But though folks who want that kind of information, let me know, and I can add that in a follow-up tutorial. In a much more concise way of generating this, you could also actually call a create method, and this actually does the same like sort of function call. It's interesting though. This one is doing something slightly different than what I had expected it to. So let me go ahead and check something out here. In older versions of Parenscript, we have uh, this ability to actually create uh, calls, but I'm wondering maybe this is create. Yeah, that's right. External. There you go. So PS create is the exported symbol for generating objects on the fly. Um, versus this, I mean, obviously you can write syntax like this. You could generate your and write your JavaScript stuff that you want, like a plus one, I think b two, and this will get generated. One second. Is legal character after colon. Um, Interesting. So you can't actually generate anything in here. Oh, wait. I thought you could do this at one point. I was almost certain that this was possible. Um, do this one more time. Compilation failed in position. New macro expansion. Got six. Oh, okay. This generates air condition and compile file. Um, what is the error? Illegal terminating character after a colon. Okay, it is actually treating this as a. I may have to do this. Too many elements in there. Okay, so you can see that it's not actually generating what I expected to. I'll look at this shorthand. There's something that I'm missing here from the older version of what I remember of it. They may have changed some stuff in some of the things to make things more consistent. But there was a way at some point that you could use this shorthand to actually create JavaScript objects. Um, but I'll go ahead and move on rather than spending too much time debugging that particular issue because we have PS create for this notion too. You can actually create your standard things like, for example, you could create using a property list here. Um, I'm sure most of you know what a property list is. This here will go ahead and generate an appropriate property list. Let me go ahead and clear this up here. And each property notice is a, a keyword is followed by a value. So it's PS create takes a keyword, value, keyword, value. Now, if you use actual keywords, all right, and remember keywords are those created by the colon. What this does is it is creating a JavaScript object, but remember this is actually creating a JavaScript object where the keys are actually strings. All right. Um, Now you may certainly be able to create, say, your your strings like this. Okay, this will do the same thing. All right, and it gets rid of it actually chomps any space after. and it'll still generate the same object. But this is entirely up to your preference as to what you decide to be useful. Once you have these objects, you can actually also call, say, get property, which is in PS get prop, and this will take in an object that you've created. Uh, let's say it's called foo, and um, you want to call. Actually, let's call the object, and let's call it foo. Here, you can see that it will generate the appropriate object.foo property. All right. Um, Now, if you wrap this, um, I believe there's a way to actually get it so that it appropriately calls out stuff. So the way you do that is you simply do this. Instead of do this, you go ahead and do that and wrapping it in a function call, and this actually generates an object. Ooh, wait. Um, that looks wrong. That's creating an object in the foo function call. Um, this needs to be. Ah, I see what I did wrong. It's not object property. This will actually generate only for object properties. This actually a function calls is going to require a different function from the Lisp API to actually create that. So let's go ahead and do that. That is the ps.chain sign. A ps.chain basically says whatever notation it is, map each one of them and construct the actual JavaScript, the appropriate JavaScript call. So if you see object, the first one is the object, the next one is going to be a dot, the next one's going to be a dot, and so forth. So if we have um, here, that will get object.foo. The other one is actually notation. So if you want to do a quick lookup using get property, because obviously the name has a name stands point, it's going to do get property. Um, Get property actually has a syntax associated with it, and it will a shorthand that you could use to actually create um, syntax, and that is the at sign. It's like there's an at sign at some point. But yeah, showing up in the autocomplete for whatever reason. Um, if you chain this multiple times, you'll see very quickly this is this also works with and without the foo quote. All right. Um, this is slightly different than the get property. Although the get property does work, notice that if we change this to that, we're going to end up actually getting a key lookup, not a dot notation. All right. Get property makes a distinction between a key lookup and a dot notation, whereas at does not. All right. This can be changed into many ways, foo, bar, baz. You could see this here. You can actually also generate, if you have numbers in between, you can, it will recognize that and assume that the bar value here before it, the previous variable before it is an array, and it will create an appropriate array syntax for you. There's so many different small nuances that you want to be aware of, right? And then finally, as I said, that you have this, you can actually create this as bar as 7, and you'll get some really nice chaining notations like this. You can actually do a lot of stuff here. Um, so let's actually see this create, let's say that we create a simple object using this, all right. Um, So you can see this object that we've created as being just a dictionary. I think most of you know JavaScript objects are act very much like dictionaries with key lookups. You can actually go ahead and define your object using this create and then create a bunch of series of syntax. And we're going to actually take a look into this when we look into our next thing, which is actually compiling files. For the moment, I am going to pause here and see if there are any questions.
I'm good.
All right, cool. Um, let's see here. Just seeing that stream settings is good. All right. So client, I see ceiling, I see chain, I see compile, script, I see file. We'll just take a source file. Okay. Let's go ahead and create a quick source file. All right. Um, and I'm just going to make a dummy file. Let's call it, we're not going to do anything related to creating a project up. That's going to be for another day. Let's go ahead and create it in this projects and say we're going to call it hello.pl, right? Oh, wait, I forgot to actually generate it. Software Lisp hello, hello Parenscript. Yes, that. All right, go ahead and create our package here. Although absolutely unnecessary, but for good hygiene, always create a package. So none of your stuff is globally defined. Um, and we'll call this AFPJS demo, PS demo. Um, what the heck? PS demo. And then we'll use CL and PS just to make things a little bit easier for us. Okay, go ahead and do that. Let's go ahead and put ourselves in this package, M package, PS demo. Good. Let's do MRS. Um, AFP PS demo. For whatever reason, sync directory did not actually work as I expected. Okay. So inside of here, we're gonna go ahead and create a couple of functions, right? Let's say we have our hello function that we saw before. This is just going to go ahead and call concatenate, and let's go ahead and create this here. Now let's do hello name, just like before. So let's define our functions, a couple of functions here. Um, and let's do uh, define. What would be an interesting one is let's say that we say by sum. Let's take this is where you could get pretty creative. Like let's do range. All right, A, B, and see how it generates. Say for I from A to B. Okay. And what I'm going to do here is I'm just kind of curious as to just playing around with this for the time being, just to see what it would do. Um, range, range, AB. And we're going to be talking about this in a minute anyway. But it's important to see some of these cool things as live from this. Um, My apologies, folks. For whatever reason, my buffer is kind of giving me some trouble here. Let me just go this way. Loop for I from A to B. Nice. All right. We actually have some pretty cool wicked stuff here. All right. Um, let us also create a basic object. All right. And we're going to use PS create to create this object. Um, and we're going to define this as go ahead and create a function called make person. Okay. Where we take as key first name, last name, age, and occupation. Okay. And what we're going to return is a PS create. Okay. Um, and there's several ways of doing this. I'm going to go ahead and use strings for this, but obviously you can create this like first name, uh, first name, and so forth. It might be better just to do first name, first name, last name. Might be even better to do this using actual standard um, notation. I'm going to use camel case to differ between the two. Last name, because it's going to end up doing something like that later on anyway for you. Age, age. Thank you. Um, okay. And we'll do occupation, occupation. But in addition to that, go ahead and do occupation. For whatever reason, I'm having some real significant trouble here for that. Okay. All right. In addition to all these, I'm going to create two functions here. One is a get older function. And this function is just going to simply be a defun um, called, and doesn't need to be a defun because we could actually do lambda take because it's going to be an anonymous function that's going to get assigned to this um, lambda. It takes in nothing, and what it will do is it will set f age uh, yes get prop. um, since we're using PSO already in our def package, I don't have to put the PS before it. Much like here, I do not need to put this here for the sake. Um, and we do obj. Uh, we need to do. I think we'd have to use. Is it self or is it this? It is. Maybe having to use this in memory for JavaScript. Just to show you how often I write JavaScript. I use Python and more than I use JavaScript. So um, forgive me, folks. Yeah, it is this. Okay. This age, and then we're going to do obviously get per. Would be even better to do this. Um, we actually assign to this. We could do this. Increment f at prop this. Okay, and we've got that done, and we have that done. All right. So we now have our basic object stuff. Let's see what this compiles to. All right. So to compile this, what we could do is we can actually go ahead and call PS. We'll take in the source file, and our source file, as we mentioned, is in software projects, Lisp projects, hello ps.lisp. And let's see, def package, hello name, range, function, slide delighted for the, my apologies. It looks like it's not, it's spitting out only a portion of it. Give me just 1 second here. This is wondering if it's already in eShell. If we have in here hello.js. Um, uh, huh. This should have generated what I expected it to. And let's see what this does. Oh, I could do that. I'm using the wrong thing. I'm using compile file, but what I really should be using is yes, compile file, element character. Element type is character. File. That's weird. This should actually generate what I expect it to, but I think the reason it's not is because although I'm treating this as a Lisp package instead of an actual um,
Lost audio there.
no. I'm still there. Um, let's see here. Oh, okay. I see what the problem is. The issue is I do not have it's eliding. Basically, um this is a result of Sly, not necessarily a result of the compilation. So we are gonna have to go in and generate our file. Let's do this. Um, Unfortunately, with Sly and even Slime, for folks who are watching, you're going to have to actually set some of this up so that you can actually compile your file. So to compile this, we have to use compile file. But since compile file depends on the stream, allowing us to actually write everything to the stream, we're gonna dump this to a file and then see this. So to do this, what we're gonna do is we're gonna first set up ps colon Parenscript stream to being a file. Okay, and we're back. So what we're going to do is to compile this file, this hello ps, we're going to have to go in and first override the parent-script stream to not use standard output, but to use a file name, so that this way we can actually go and generate this. For folks who know this, this is just simply calling with open file on, let's say we call this software projects, list projects, hello ps.js, since it doesn't really matter right now. And we have to provide the direction, output, and obviously for to being completely safe, always we're gonna always overwrite this because we're gonna generate the same file every time we call this guy. All right. So um, we can now call ps compile file on we're doing before, which is software projects, list projects, hello ps.lisp. Okay. And when we do this, we got to dump. Let's go back to our shell. And if we do a ls grep hello, you'll see hello ps.js there. And if we open up this file, you'll see that it generates the full code for us as we expect. Again, folks watching asking what this is all about. I'm not entirely sure what this Dunder PSMB reg is all about. I have to go and look into that. That's probably a consequence of the transpiler that's being generated by uh, Parenscript. But in general, you could clearly see that this is fairly close to what we were kind of expecting. Now, the one thing that surprised me is although loop appropriately generated into a correct var, a for loop, pushing stuff and returning the collection here. I was surprised that this piece wasn't necessarily flattened. I would think that that might be maybe a secondary pass. Once it is, there might be a rule where if it sees list forms, first generate the appropriate list form to the correct JavaScript code before doing additional passes to optimize and clean up the code. But that was a bit surprising to me. But if we go to our range, more or less this function matches kind of what we expected a JavaScript code would look like. Um, the one thing to note here is for make person, this might be a bit surprising to some folks where it's grabbing the arguments and then generating based on the arguments passed in the appropriate structure for this, and then it will actually go in and generate the actual construction of the object. Now, but everything else looks kind of more or less the what I expected it to. Like for example, our get older function here is clearly appropriately calling out to. Oh, it looks like I have a typo in my generated code. Okay, so give me just 1 second here. I made a mistake in my other Lisp code, and this is treating it as a object lookup than a dot notation. That can easily be fixed. Here the get prop, I have to use ps at um, and if I do E, it should get loaded. Hello ps.js. Me again. E shell arm just to be clear about this. And yeah, now load this up. What is this doing now? This is still doing the @, doing the appropriate object lookup. This dot age is what I kind of wanted. Okay, give me a second. There's one more thing I need to do. Okay. Oh, I forgot to save. That's why. Shoot. All right. I got my face. Um. Okay. Oh, I don't. There we go. So, as you can see here, this now kind of matches what we expected to. Um, the get older function is a now an appropriate function call. It is appropriately accessing using the this notation. The syntax set fs are all appropriately generated. But again, I'm a little surprised by this notation here. Um, I was hoping that this would become an appropriate function call, but it looks like keyword arguments are not well liked in this code. So let's go ahead and fix that. Um, you and where are you? Make person. Go to this here and that. There we go. Now everything's appropriated. Now everything's properly cleaned. So this is a very quick notation and quick introduction to the basics of Parenscript. I really didn't want to delve into other stuff like the document APIs and stuff like that because I think it would be more appropriate to first show you guys a more full-featured application, like a to-do application of some sort. So I'm working through that right now. There are a couple things that I'm still not aware of. Like, for example, I'm just going to show this to you. So, uh, for class objects, okay. And what I mean by class object, I'm not talking about what I just showed you here. That's creating an ES5 version based class object, and that is a perfectly valid JavaScript that you could do even today. But if you're using, say, React, just for the sake of example, React and a lot of these newer libraries are starting to leverage class syntax, which because class is part of the ES 2016 standard and later. And so some of the newer things like register element for creating custom elements and things like this um, are part of those APIs. Obviously, there might be ways of leveraging those using standard ES5 syntax to actually go in and construct custom elements in a very ES5 standard way, or even later. But I'm trying to figure out a way to actually go and use the newer versions of the syntax. So this way we can actually leverage Common Lisp and still get modern JavaScript for folks who want to leverage modern JavaScript. and not just the APIs available. But that's going to be as part of our to-do application demo. Um, I'm I think there is a particularly interesting point about again the state of Parenscript. Parenscript is still actively being developed, as much as I can tell. The documentation has been updated in 2018 when and there are new releases, at least from what I saw earlier. But keep in mind that there are two different types of parent scripts available on Quick Lisp. For those who are using ES5 standard like syntax, there is obviously parent script classic, and now there is, of course, Parenscript 2.71, which is available on Quick Lisp today. Next time, we're going to explore writing an application using this, and this will also require us to use CL I'm gonna hopefully start setting this up so that we can potentially create a static website using all this because again, I'm of the feeling that if you can create a static website, you should do so just because you could then deploy on a CDN very quickly and leverage the CDN's ability to uh, go to local area geographical regions so that way your site has more reachability than requiring you to actually go and then scale horizontally. You get the horizontal scale of your static site for free, and it's connected to web services that are hooked on the back end, hopefully through some serverless like architecture. But that is still in the works. I'm hoping to start the live coding sessions next week. So if there aren't any more questions, I'll take questions now. But if there aren't any, I will end the conversation today. I see a comment from our some of our folks in the in the YouTube channel. Yes, I'm finally getting back to doing more web development in Common Lisp, and I've been looking into this for some time. I'm hoping um, for some experimentation because right now, as you can see here, um, this while this is great, um, if we're starting to write larger and larger sites, although it's okay for getting this generated JavaScript. Having it as close to what someone might see in production JavaScript code nowadays using ES 2016 might be useful. Um, but you could certainly use some of the standard uh, JavaScript functions that you might be aware of in the console. Um, so, like the document. We go and do PS compile stream. Not compile stream, sorry. Let's go back to our scratch buffer. Give me a second here. Um, and recall in our scratch buffer, we have this. Okay. And what we can do is we can actually leverage this to generate um, it's clone. Uh, that's was been looking into this for some time, and I've just I think it's objects.freeze. There's an objects API now that's available in JavaScript. That it's I think it's just object. It might be just object dot create, and then there's also object.freeze. So if you want to use the newer syntax, at least for uh, leveraging um, ob- object.create, for example, you can certainly do so, and we'll go ahead and generate what you expect it to do, which is uh, it'll create instead of what you saw before, object.create will actually go in and call the create method that's part of the object API. And I think that's another way of actually doing what we kind of expect it to do. Um, just make sure something here. Um, okay, so I'm just going to pause for a moment to see if there are any questions, and I'm just going to do a couple of additional explorations in the meantime, just to see if let's see. Looks like we're good. So we can actually create. So for example, if we do object.freeze this and we provide some obj, we can actually do that. Oops. Oh, in this case, we'd have to use chain though. Yeah. Is that creating a, it should be a capital. This should not, um, okay, there is one bug here. Looks like I'm going to make a note of this. The object API should not be lowercased like that. I don't think it shouldn't. I don't know if it matters or not, but I know that looking at the old or even the console, if you fire up Chrome console, you get some. It looks like it lowercased it. Okay, I'm gonna keep an eye out for this. See if there's a way to fix this because I think this is important to keep in mind. All right. So if there aren't any if there aren't any questions out there, folks who are watching this later on, again, I don't think I have to repeat myself, but in case I do, put your comments in the YouTube comments. Like this video if you can. Obviously, AFP is looking for speakers, so those of you who are willing to speak about functional programming in general or anything related to Lisp, and we're all Lisps and all functional programming languages are welcome in our group. Feel free to drop me a line, and we'll get you on the schedule. Um, Next time, we're going to be hopefully writing out a basic to-do application in Parenscript. I'm going to look at some additional things related to how to set some of this up. If something changes, if you're in the functional programming Slack channel, I will certainly let you guys know. Otherwise, thanks for joining us. Have a great evening.